The following problem can be found in this book on the notation to the right.
Hello everybody, I'm Anthony. Today we'll be addressing this problem. A roller coaster reaches the top of the steepest hill with a speed of 6 kilometers per hour. It then descends the hill, which is at an average angle of 45 degrees and is 45 meters long. Estimated speed when it reaches the bottom. Assume that that new k is 0.18. Okay, so let's just get some things ready here. This angle down here is 45 degrees. Actually, let me draw that on the other side. This angle right here is 45 degrees. And this distance right here to the bottom is, this distance right here to the bottom is 45.0 meters. Now that we have that information, let's do some things. First, let's convert that kilometers per hour to meters per second. So let's go up here, convert it up here. 6.0 kilometers per hour times 1,000 meters over 1 kilometer times 1 hour over 3,600 seconds. Chop. No, I want the seconds. Chop suey. So we have 6,000 over 3,600, which is about 1.67 meters per second squared. That's the acceleration in meters per second. Okay, now we draw the free body diagram. This will be the roller coaster. This will be the angle. Let's see, the force. There's no force acting on it, so it's just the force of gravity, which is mg, that's acting on it. Let's see, this way it's being pushed forward at 1.67 meters per second squared. Here, this is the normal force, just opposing mg. And this right here, the force of friction, is nu k times normal force. Sorry, that's really messy. I'm gonna move over here for more space. So then, let's figure out the angles. Actually, the angle is, 45, but let's figure out how that affects gravity. If we just draw this right here, this is 45 degrees up here. This technically is 45 too. I'm just gonna say this is 45, and two 45s over here make a 90-degree angle. So the force of gravity in the x direction is mg sine of 45 degrees. The force of gravity in the y direction is mg cosine of 45 degrees. Now, let's plug that into Newton's law. Summation of all the forces in the x is ma. So the summation of all the forces is, well, we have this formula that has been derived, so we're just going to plug that in. So mg sine of 45 minus 0.18 mg cosine of 45 equals ma. Since the m's don't really matter, let's just cut those out now. They're not important to the acceleration. So that's g, technically g times the square root of 2 over 2 minus 0.18 g's times the square root of 2 over 2 equals the acceleration. So the acceleration is 6.93 minus, that's not a 3, 6.93 minus 1.28. So the acceleration is 5.7 meters per second squared. Now that we have the acceleration, we have to find the speed when it reaches the bottom. So kinematic equation time. Aren't those always fun? So here we have x initial to be 0 because we're at the top of the hill. X final to be 45.0 meters. Acceleration to be 5.7 meters per second squared. Sorry, that's ugly. Initial velocity to be 1.67 meters per second. Sorry for this mistake earlier where I put squared up here. It's supposed to be just 1s, not 2. And v equals, we don't know that. That's what we're looking for. T equals, we don't know that either. So I'm going to pull out some kinematic equations and okay, so let's take formula number 3, which is v squared equals v initial squared plus 2a x minus x initial. So that's v squared is 2.7889 plus 11.4 times 45.0. V squared equals 2.7889 plus 513. V squared is 515 times 7889. If we square both sides, our final answer is the velocity at the end of the 45 meters is 22.7 meters per second. But due to significant figures, the final answer is 23 meters per second. Thank you for watching. That is all.